website, so you can have a look with the software for Mac and Windows. And the final result, something like that. But wait, I really need to show you a part of the documentary they made.
We're gonna print our head for the tripod.
What are you gonna print?
The head for the tripod.
Oh yeah, that's a good one.
Actually, no, it's not YouTube, but bear with me with a second. No. Sorry, no, it's not this one.
Not in favorites.
Are you going to do a demonstration?
No, I'm gonna show you the final result because I tried the software, but without the tripod it was a little bit difficult to test it properly. If I can. Okay, because the connection is quite slow now. Okay, so in a minute I'll show you the project. That's my idea. And now, Phil, if you want to go to the second presentation until charges just a minute. So, because you really have to do this video, it's amazing.
Wanna stay here?
Yeah, maybe I can sit over here.
That's nice.
Yeah. Do you maybe want to let it buffer for a little while longer?
Well, okay, guys, you can follow the link. Let's move on. Let's move on. Thank you.
Yeah, I think that's a really great idea. Is this long enough? Let's see if we can get this to work. Yeah, so what I'll be talking about is not so much a project that we can immediately start on building all together. It's just when I heard about the idea of the VideoHackSpace, I immediately had to think of a project that I recently finished, which is actually my master dissertation project, which is about interactive video.
Can you just pass it up, Jack?
Yeah, absolutely. There you go. So since this is my dissertation project, I'm going to, what I will be presenting is the presentation that I used for basically my the presentation that I used to defend my dissertation. So we'll be a little bit academic perhaps compared to the other presentations, but yeah, I'll walk you through it. Is this visible?
Sorry. kind of.
So, I studied cognitive computing at Goldsmiths College, and I am from an artificial intelligence background. And what I was trying to do in this project was really to solve a problem of that exists with online video in particular, and visual content in general. And so the name of my work was Using Computation in Online Video Storytelling. Yeah, so what I'll be talking about just now is first I'll explain sort of the problem that I'm trying to get at with this project, which is that understanding video is really hard for computers. Understanding visual content in general is really hard for computers. So I'll talk a bit about what kind of ways people are currently using to sort of solve this problem computationally. But what I have investigated is sort of like a different way around it, which is not a computational solution, but it's basically asking lots of people to give input and help with the computational process. So I'll talk a bit about that, and then I'll show how I used that kind of solution to filter videos, to filter online video material, and reconfigure them in new stories. And so the name of the project that I built was Reporter. So I'll talk a bit about that. And since we're here together in the Hackspace, and it's nice about sharing skills and sharing knowledge. Yeah, it's also a bit about the whole idea of opening up video. No longer looking at video as just a black box that sits on YouTube, and the information that we have about it is just in the metadata and in the description or the title, but really trying to look at ways how can we go deeper into a video. That's really what interests me. And so what I've used in this project for that is popcorn.js, which is a JavaScript library, and lets you do really cool things with a timeline. Any timeline or time-based medium, like video, but also audio, you can do really cool things with it. So I'll also tell a bit about that. So just to explain a little bit of what this problem is that I'm trying to solve, is here a little demonstration. This is just a video. Maybe we can also have some sound. And for us humans, it's really easy to understand what's going on here. We can immediately see, we don't even have to think, it seems. We can immediately see, okay, there's flags here, a particular kind of flag, it's the Union Jack. There's a luxury car passing by. There's, maybe if you have good eyes, you can even see that there's a woman wearing a hat in there. And there was it already. So any idea what you might have been looking at here? Anyone?
The Queen passing
by. The Queen passing by during the Jubilee celebrations in London this summer. So,
Strand.
Sorry?
Looks like it's on the Strand.
Exactly. So okay, so this is just a demonstration of how good we are at interpreting visual content. However, what a computer sees here is just a matrix of color values. So it's incredibly hard for a computer to get these kinds of semantical concepts, to detect those from video material, or even from any visual material, let alone video material. So this is basically, just to recap what is happening here. We have the world. We sense the world through some kind of camera, and we get a representation of the world, which might be an image or a sequence of images, in this case a video. And then what happens when we see this, just now, we understand and we interpret, and we understand and recognize a couple of high-level semantical concepts. So we can understand that there is a car in here. There's perhaps even we see a queen, we see flags, and we understand something about the Jubilee. For computers, however, this is really difficult, and so we might try to do the same thing with computers because it's really useful. Imagine, well, there's loads of these videos online. If you want to search them, you would like to have these semantic concepts in the form of labels tagged as metadata to your video in order to more efficiently search, reconfigure, recommend and all of that kind of stuff. So that's what I as an AI scientist, I'm interested in these things. So there's a couple of reasons why this is currently difficult. First of all, there's a gap in between what is out there in the real world and what is present in the data that we get, that is basically present in this representation of the world, and that's called a sensory gap. So that means if I take a picture of all of you, then this picture or this video doesn't entail all the information that is present here in this current space, which is, I think, an infinite amount of information. So you can never capture all of that in a single representation, not even in a sequence of representations. So that's just the sensory gap. Then there's a second gap, which is the semantic gap. And that's the gap in between the representation of this world and all the data that is in there, described in low-level features that are accessible to a computer. So for example, color values, edge detection values, resolution, metadata, etc. And on the other hand, high-level concepts such as car, queen, jubilee, etc. Actually, this has a nice scientific definition. The semantic gap is the lack of coincidence between the information that one can extract from the visual data, from the visual data, so that's here, and the interpretation that the same data have for a user in a given situation, right? So there's this discrepancy between what is present in the data and the high-level concepts that we assign to it. So how might we solve this problem? I have a couple of friends studying computer vision and computer graphics, and the solution the way that they try to solve this is they take images, they take lots of images, they extract features about color, about edges and all that kind of stuff, and they take all these features that together represent the image, and what they then do is they do something which is called supervised learning, where you take a lot of examples and you know a certain classification. So for example, if you want to train a computer program to understand or detect queens, you give 100,000 images of queens represented by all of these features, and you hope that the features encode useful information about there being a queen in there. And you also do 100,000 images that do not contain queens. You feed it into the program and you say, this is a queen, this is not a queen, this is a queen, this is a queen, this is not a queen, etc. So that's supervised learning. You learn by giving supervision. And then you have a queen detector. You build an artificial queen detector. And you can do the same thing for cars and for flags, etc. Maybe for Union Jacks it's even quite possible to build this successfully. There is a couple of problems, however, is that these kinds of algorithms, they fail to perform reliably and generally. And that basically means, like I said, for example, if you have pictures of a certain framing and consistent lighting conditions, and it's just pictures of national flags, well, then I think I will be able to build a program that detects Union Jacks. And maybe even also the Brazilian flag and discern it from the Japanese flag. But as soon as you go into a wider domain, for example, any kind of picture or just pictures on internet or even worse, all the video on YouTube, that's almost the widest domain as you can get, because you never know what to expect. All the conditions are always different. And that basically means that the semantic gap there is as wide as it can be. So that's really problematic. So this is a little bit about what I'm talking about here. This is user-generated video content on YouTube. Or actually this is all the content on YouTube, which is mainly user-generated. And so in, let me see, October 2010, they were blogging and they said, oh, this is amazing. We have currently, 36 hours of video uploaded each minute. But at the moment, we're here in January 2013, at the moment every minute, we together with the whole entire world, we upload 72 hours of video per minute. That's 72 minutes every second uploaded to YouTube. That's more than an hour every second. So there's no way that all these algorithms can keep up with that.
How much of that is cats?
I haven't looked into that, but I think that's a good project to do.
Won't that be a good way to start? Because cats would be easy. The pattern would be very easy. Like,
Yeah. And then you might be asking yourself the question like, yeah, now we have a cat detector, and what do we want to do with that? Maybe we want to also distinguish certain types of cats, or happy cats, and okay, whatever. Cute cats, of course. So there's also this other solution, and that is it's called human computation, and this has been recently made very popular, mainly by a PhD dissertation by a guy called Louis van Aan. He also made Duolingo, which you might know of, which is a website where you can learn a new language and at the same time translate search results. So super useful. So the idea is we have a task that is really difficult to solve computationally. Computers suck at this, so what do? We want to solve this problem. Well, we divide it up in little tasks and we give it out to people. And so this guy, Louis van Aan, he's also the inventor of reCAPTCHA. So first he invented CAPTCHA, the CAPTCHA system, which is, well, you all know these, so I don't have to explain this. This is basically to prove that you're a human. And then he invented